Okay, thank you for joining everyone. It's 2 o'clock, and so I'm going to turn this over to our presenter, Jesse Manship.
Hello and welcome everybody to Madico's April webinar series. Thank you so much for attending our online training. I'm Jesse Manship, Technical Service Engineer with Madico. Madico Technical Services Department is here to help support our dealers, their customers, and our sales team. We offer support on commercial solar and safety jobs, answer questions on a variety of topics from our films to glass, our warranty, energy analysis, and film to glass compatibility. Further information is available on our website. We also have Madico's technical resources at Madico.U, Madico.com/MadicoU, or by following Madico.com and clicking Madico.U in the upper bar. Technical resources are just one part of Madico.U. We have resources on film benefits, a glossary of common terms, and film facts. In addition, we have product training videos for you to explore. This is just a list of some information on Madico.U, a glossary of solar optical properties, tools, which we'll be discussing today, installation instructions and tips, and frequently asked questions. Glass is very important in our modern life. It's a key component to every building and home. In our previous technical series, we learned about glass and what to look for in determining the safest solar film for application. Today, we'll look at some of the glass meters and tools you can use. Also, we'll review some of the tools you can use in your shops and in the field to demo to the customers the benefits of film in reducing heat from the sun. Windows are fabricated with clear, tinted, and coated glass. Variations in the tinting and coatings influence the solar and optical and heat absorption properties of the glass. Total absorption is one of the most important properties in thermal stress. Tinted glass is manufactured by adding colorants to the clear glass. The total absorption can vary from 1% on ultra clear low iron glass to over 90% on colored glass. Often then, color can be closely related to the absorption of the glass. One other thing to consider is darkening the glass too much, and you can increase the amount of lighting that the customer has to use on the interior of their home or business, which can cause an increase in their energy bills. What about cars? I'm going to ask you to please reference the tint laws for your individual state. The IWFA provides a chart with each state listed at iwfa.com/news-events/state-laws.charts. It's a very long path, so the best way is to go to iwfa.com and then search for tint laws. You can use your VLT meter to determine how dark you can tint each car legally. If cars and trucks have factory tinted glass, you will be reducing an already reduced light transmission. So for example, using a 35% VLT film will not net 35% VLT if the glass is already tinted. There's two main styles of meters that can measure the visible light transmission. The first is a horseshoe style, commonly used for flat glass. Madico offers the Spectrum Detective Meter. This meter can demonstrate three performance characteristics at once: UV, visible light, and infrared transmission. This is an effective way to show that the film will help prevent fading. Simply slide the glass into the opening and see the result values displayed. There's no additional light sources needed. The second and third styles are used in the automobiles. The first style is an over-the-window style. The Tint Check Autometer measures visible light transmission on roll-down windows. It's a much smaller meter than the horseshoe style and can fit comfortably into a shirt pocket. The tool is calibrated to a NIST traceable standard. The next is the Tint Check Plus automotive meter. It measures visible light transmission on roll-down windows as well, and has all the benefits of the Tint Check, plus it features a backlit LCD, making it easier to read in low lighting conditions. It also reads 0.1% greater for greater accuracy. The last is the Enforcer 2. It's a lightweight pocket-sized tint meter. It comes equipped with a coin cell battery to last for 2,500 uses. It auto calibrates. This one's also for roll down windows only. The last style is a clamshell style, like the Inspector 2. It's the newest in light meter technology, allowing you to measure all windows on the vehicle, including the front and rear windshields. Auto calibration accuracy to within 2%. Just like tinted glass, low E glass also increases the absorption. It's important to know if the glass in the window contain a low E coating. Most of these coatings are invisible and have very little reflection. For comparisons on absorption, a clear low E, low iron glass has the lowest absorption of about 4%. However, low E on a normal glass will increase to around 15%. If they use a triple silver coating, like Cardinal Low E 366, that absorption increases to 36%. If the window is also tinted with a low E coating, that absorption can easily go beyond 50%. There's many models of low E detectors on the market. An economical version is the low E coating detector by ETECT. This detects the presence and location of the thermal resistance coatings, more commonly called low E, that are used on energy efficient single and double pane glass. It never requires calibration, and it's powered by a 9-volt battery. Handheld in size and completely portable, the tool is capable of measuring 3/32 of an inch through 1/4 inch single pane glass. It's also compatible with 3/32 of an inch to 1/8 inch IG units, with 1/4 to 9/16 of an inch airspace from a single side. This means that thicker IGUs, as well as larger airspaces, must be tested in a single pane mode, meaning that you test the window from both sides to determine if the pane you're in contact with contains a coating. On the bottom, there's an example of a measurement from 4 different conditions and the results that would be displayed with the tool. Please remember, though, the numbers that we're talking about here are relative to the tool and not to the sun, as we commonly refer to in the window film industry. So from left to right, near means that the coating is on the pane that the meter is touching, but the meter is not touching the coating. So you can see there that it's on the same pane, but it's on the second surface of that pane. Far means that the coating is on the other pane and the meter is not touching the pane with the coating. Clear means that the meter does not detect the coating, and then contacting means that the coating is on the pane that the meter is touching and it's touching that coating. Another meter that can detect low E is the Glass Check Elite. This is a top-of-the-line detector. It can even identify laminated glass in a window and measure the thickness of the laminate interlayer. It has a graphical display with window illustrations. This shows the window drawn approximately to scale and assigns numbers to each pane of glass and the surface of the window. It's a great visual aid in understanding the exact makeup of the window and identifying the low E surface coating. It's also able to measure triple pane glass thickness, airspace, and overall IG unit thickness of a triple pane window, all with a single press of the button. It works with single and double pane applications as well. The example above displays the measurements of 2 panes of glass, one single and one laminated, G1, G2, and G3, and the airspace, A1, and the laminate interlayer, L1, and the total IG thickness, total. Each pane of glass is clearly labeled on the illustration, showing that there's an airspace between G1 and G2, and while the laminate interlayer is found between G2 and G3. The meter can detect the location and determine the type of low E coating present. The glass check is capable of locating the low E coating on a double pane window from the single side. This is a major advantage over the previous meter, since if you're testing on a multi-story building, you would only have access to the inside. More importantly, the Glass Check Elite displays whether the coating is hard or soft low E. When the soft low E coating is detected, the meter classifies it as a single, double, or triple layer of silver. This enables you to identify the low E coatings that you find in the field. Glass and airspace thickness is important to know How thick the glass is before we apply film. Simply put, thicker glass is more absorbing. As an example, clear glass that is 1/8 of an inch thick is about 8% absorbing. When you go up to 1/4, it's about 14% absorbing. 5/16 is about 18% absorbing. And 1/2 inch is about 25% absorbent. Remember, that's just clear glass. It's not tinted, and it does not have a low-E coating. Airspace thickness helps with insulation, or the U factor, and slows the heat transfer through a window. The temperature in airspace can vary based on the thickness. Madico recommends the insulated glass thickness and gap gauge. The tool is used to measure glass and airspace thickness in sealed IG units, laminated IG units, and even triple pane units. It uses a laser reflection, and these reflections off the glass surface appear on the graduated scale of the gauge, allowing you to easily determine the thickness of the glass and the airspace separating the pieces of the glass inside the IG unit. There's 2 examples on the screen. The first at the top is a single pane with a 1/4 inch thick glass. And the second is a double pane with an 1/8 inch thick and then a 1/4 inch airspace. Please note that there's 2 scales. The top one measures the airspace, while the bottom one measures the glass thickness. Be sure not to confuse the 2 when taking your measurements. Completely portable and powered by 2 standard AAA batteries. The strength of the glass is greatly increased by heat treatment. Heat treating is a process of heating the annealed glass to its softening point and then rapidly cooling it. The rapid cooling cools the surface faster than the interior, locking the glass into a constant state of compression and tension. Tempered glass is safety glass, while heat strengthened is not. Both can receive any type of film without the risk of thermal fractures. Look for the safety bug in the lower corner of the glass. In some cases, the glass was put in upside down and the safety bug is at the top. The etching will indicate which type of safety glass it is: tempered, heat strengthened, or laminate. The strengthened glass detector allows you to confirm if the glass has been strengthened. The detector can test single or multiple panes of glass all at once from either side of the window. As a bonus, the detector can even identify the thickness of the first pane of glass. To use, slide the meter across the glass and watch the reflections from the glass head on. As the meter crosses stress lines in the glass caused by the strengthening process, the resulting surface reflections from the light sources will change color. The special optics of the meter provide a vivid color change, and it's great for applications where the stress lines are more difficult to view. The meter has a reflection on each surface of the glass, with each pane having a front and back surface. There's 4 examples on the screen, 2 with a double pane and 2 with a single pane. In each, the right-hand side shows the heat strengthened glass. On the top, one of the 4 columns, it shows a different color on the number 4, which indicates that the outer pane is strengthened. On the bottom, there's a different color on the number 2, indicating that this pane is strengthened, since it is single pane. Data loggers and IR cameras can be used to show the reduction of heat transmitting through filmed windows. USB data loggers are used to track the temperature difference of a space with and without film. A film sample must be installed, then the data loggers are left behind the film glass and behind the adjacent unfilmed window. These prove that the film is rejecting heat and lowering the inside temperature. These are often used to dispel the misconception that window film does not work since it makes the glass hotter. You don't have to let the film dry. You can install it and put the loggers there and then come back in a week or maybe 3 and retrieve your data. On the right-hand side is an example of the data logger, tracking the inside temperature of a room with and without film. It provides a clear view of how much cooler a building can be by installing window film. Temperatures can be measured for as long as you desire, and the data logger software will automatically graph the results for you. The information gathered by the data logger can be useful to satisfy requirements of the International Performance Measurement and Verification Protocol, a widely accepted standard for measuring effectiveness of energy-saving products. For instructions on how to use your data logger, please reference the included software. Also, Technical Services is here to help you if you have any questions. One reasonably priced IR camera is the FLIR One Pro. This device attaches to your Apple or Android device and turns it into an IR camera. Madico does not offer these, but you can find more information on the FLIR website on how to purchase. IR cameras need to be used properly. Do not take a picture of the window itself. Take a picture of the space inside the window, either the furniture or the floor. The space inside will be cooler, whereas the actual glass will be hotter with film. The photo on the left is film installed, and you can see it in that center pane window. You can see that it's slightly darker. The IR photo on the right is the same picture, but of the floor of the inside center window. Again, the left side is filmed, and you can see how much lower the temperature is with the film. These are some examples of tools that are great for showing the film's performance as a tabletop demonstration. Each of these can be used with architectural or automotive films. The demo can be in your home, in a home, or the shop. Madico offers two different light sources, a heat lamp for IR and a UV lamp. Using these light sources, you can then set up your sample on the sample glass set. Depending on the light, you will choose which meter to use. The UV Sentry measures UV only, while the BTU transmission meter measures BTUs and solar transmission. These tools help you know exactly which type of glass you're working with. This helps you offer the best and safest solution for your clients. They show to your customer a high level of professionalism and help you to remove price as the driving factor. Also, just a reminder, Madico's technical resources can be found at Madico.u, Madico.com/Madico.u, or by following Madico.com and clicking Madico.u in the upper bar. We have one more upcoming online seminar with Madico.u as part of our April series. On April 29th, Clearplex installation training. That concludes today's. Are there any questions?
Jesse, we have had a couple questions come in. One of the first questions was, does Madico sell all of these meters that you covered?
We sell every single one of them except for that FLIR attachment on the iPhone or Android devices. For that one, you'll have to source it through FLIR.
Okay, and then another person asked, I was always told from my research that the outside of the outside pane is surface number 1. Is that not correct? I think one of the illustrations showed the inside being surface 1.
They are correct. I'll go back to that slide just so that we can clear that up, because I don't want people to be confused by that. I'll give it a second because I'm not sure how fast the upload goes. So this tool is measuring differently in regards to surface number than we traditionally refer to surface numbers. So the surface number, when we're talking about, is always from the outside in. The tool, though, in this diagram references them a little bit backwards. So they're talking about pane 1 and pane 2 and not necessarily the surface, okay? So rather than confuse you, let's just always think about the outside surface as number 1, and then going from outside in, 1, 2, airspace, 3, and then 4. For here on this tool, it's simpler just to remember near, far. Near meaning that it's on the surface that you're touching, on the pane that you're touching, and on the second surface of that pane from you. Far meaning it's on the opposite pane from you, and you can't really determine if it's on the near or far of that pane. I'm sorry to make this one a little confusing. I took it out of their installation instructions.
And then there's another question about data loggers, Jesse. It says, when using a data logger, is it efficient to leave the data logger with side-by-side glass, one with film and the other without, or just by room?
So so with the data loggers, this wasn't a full installation instruction, just to give you an idea of what you can do with the tool. But with the installation, you'll want to pick 2 rooms that are of similar size and shape and similar furnishing. So you don't want one to have a lot of furniture and one to have no furniture. And then you'll want to make sure that they're both set to the same temperature. If one person has the ability to control their temperature, they could skew your results and make it look like your film is performing very well or very poorly. So the temperatures need to be the same set point for each room. And then you'll film one room and you'll leave the other room as is conditions. And then you'll center the device about 3 feet away from the window and then behind the window, directly behind the window. And then you'll leave it for a couple weeks and then you'll come back. The picture that's shown is only a course of 3 days, but you can certainly plot many, many more days and you can show them how much that more comfortable the room is by keeping it at a more comfortable temperature.
Great, thank you, Jesse. We'll give it 1 more minute. If you have any questions, please enter them into the chat box. Jesse's available right now to talk about any of these meters that he went over. And just as a reminder, all of the webinars from April have been recorded and they all will be posted to Madico U. All of the past webinars are already in there. But all of the future ones from this week will be in there by later this week. 1 more question, Jesse. Should we always number from outside in for pane numbers?
Yes, we should. So the numbering order should stay consistent for everyone. So the outside pane has 2 surfaces, the outer surface, which the sun hits first, and then as the sun goes through it, it comes out of the second surface, goes through the airspace, then hits the inner pane, which would be the 3rd surface, goes through that pane, and then out of the 4th surface. That installation instructions for E-Tech is a little bit confusing. So if you're using that tool and you're concerned about which surface number to be writing on there, you can give me a call and we can go through it together in more detail. I don't want you to be confused.
Okay, thanks, Jesse. I think that's all the questions. Thanks, everyone, for joining our webinar today.
Thank you, everybody.